A very good morning to everyone. I am Hemendra Patil, and today we will discuss about the properties of fluid and basic things about the fluid mechanics. First, I will give some introduction about the fluid. What is the fluid? Fluid is defined as the substance that continuously deform under an applied shear stress or under an force. Regardless of the magnitude of applied stress, it is a subset of the phases of matter and include liquid, gases, plasma, sand, to some extent plastic solids. If we are discussing about the fluid can deform under very small force, or we can say a very negligible force. You can see in the image I have given a glass which contains the water. So material that can flow and take the shape of its container is called the fluid. Now coming to the fluid mechanics, the study of physics of materials which take the shape of the container or branch of engineering science that studies the fluid and the forces which are acting on the fluid and the behavior of fluid is called the fluid mechanics. And for more understanding, we can further classify the fluid mechanics into the fluid statics, fluid kinematics, fluid dynamics. If we see the fluid statics, the study of fluid at the rest is known as the fluid statics. Whereas in fluid kinematics, the study of fluid in the motion, if we are studying the fluid during its motion, that is the fluid kinematics. Whereas in fluid dynamics, we study the fluid in the motion while considering the forces which are acting on the fluid and causing the motion. So basically, these are the three category of fluid mechanics: fluid statics, fluid kinematics, and fluid dynamics. Before coming to the basic properties, we must know about the solid, fluid, and the gases. What is solid, what is the fluid, and what are the gases? So, what is solid? Solids are the definite, solid take the definite shapes and definite volume, and they does not flow easily. And if we will see the molecules of the solid, they are very close. In fluids are of the indefinite shape and indefinite volume. It assumes the shape of container which it's occupy, and they flow very easily. If you apply some force or very negligible force, it will continue to flow. And if we will see the molecules of fluid, molecules are very far apart with respect to the solid. In solids, the molecules are very close enough. And if we will further classify the solid, there are two types, we can say. The first one is the ideal elastic solid, and the second is the plastic solid category. In ideal elastic solids, the solids which deform under the load and come back to its original position upon removal of the load. Here, if we will see the different material and their properties, like if we will take the example of a steel, if we are applying some force on the steel, so it will extend to some part and come to its original position. But it depends upon the forces which is acting on it. After some limit, it will also not come to its original position and it will show the plastic behavior. But some materials are completely plastic solid. Applying the load, it remain in its the position where we leave it after applying the force. So the plastic solid does not come back to its original position upon removal of the load, means the permanent deformation take place in the plastic solid. Whereas in elastic solids, permanent deformation does not take place. If we will see the attractive forces between the fluid molecules, the forces are very small, and the forces acting between the same type of molecules in the fluid is known as the cohesive forces. Basically, there are two type of forces, we can say. If the forces are acting between the same type of molecules, we can say the force is the cohesive force, and the force acting between the different type of molecules. Let us take one example. If the molecules of water and the molecules of glass, we are taking the example of water and glass. If the molecules of water and molecules of glass are attracting each other, then that force is known as the adhesive force. Here come one concept. of wetting and non-wetting liquids. Some of the liquids wet the flour or wet the different material which come in contact with them, and some of the material does not wet the flour. So the basic property of fluid which act behind this is the cohesive force and adhesive force. If the cohesive force is very large in the fluid, than the adhesive force, so it will not wet the flour. We will take the example of mercury. Mercury have a very large amount of cohesive force, so the molecules, same type of molecules attract very much rather than the other type of molecules. If mercury is on the floor, then the molecules of mercury on the glass will apply very less amount of force than the which is applying on the same type of molecules containing in mercury. So it will not wet the floor. But if we will take the water on the floor or on the glass, it will wet the floor or wet the glass. The reason behind that is the cohesive force is very less rather than the adhesive force. Now, if we will see the gas, difference in the gas and the liquid, the molecules of gases are much farther apart than those of the liquid. Hence, a gas is very compressible when all external pressure is removed. It tends to expand indefinitely, whereas a liquid is relatively incompressible. If all pressure except that of its own vapor pressure is removed, the cohesion between the molecules hold them together, so the liquid does not expand indefinitely. It will expand to some moment, expand to some moment, but after that it will stop and it will not expand to indefinite. Therefore, a liquid may have a free surface. Now coming to the basic properties of fluid. Density. Density is the very basic things. I think everyone know about the density. The density of a substance is the quantity of matter contained in a unit volume of the substance. Suppose 1 liter cube, 1 meter cube of volume contain 1 kg of mass, then the density of the material will be 1 kg per meter cube. If you will see in gas, liquid and solid, as I was showing you the image here, in the gases the density is very small because the gas molecules are very apart from each other. In the liquid, the density is larger than the gas because the cohesive forces is larger than the gas and the molecules are denser than the gas. Whereas in solid, the density is very high because the molecules are very compact and in very large amount in a unit volume. Here I have taken some example. In first example, you can see there is a cube of 1 meter where mass is 10 kg and volume, if we will see, a cube will come to the 1 meter cube. So if we will want to know the density of this cube, so density will be the mass by volume. Mass here given is 10 kg and the volume, if we will calculate, of the cube will come to 1 meter cube. So the density will be the 10 kg per meter cube. In the second image, if you will see, the cube is the same. Cube here is the same of 1 meter, but mass is changed. Mass here is of 20 kg. So density will come the 20 kg per meter cube. So it is very simple to calculate the density of any object or a mass. Now the second property of the fluid is the temperature. Temperature is the property that determines the degree of hotness or the coldness or the level of the heat intensity of the fluid. Temperature is measured by using the different temperature scale. There are basically 3 temperature scales generally used. They are Celsius, Fahrenheit scale and the Kelvin scale. You can see in the image I have shown here Fahrenheit, Celsius, 2 scales and in the thermometers. Now coming to the next property, the pressure. Pressure of fluid is same as we calculate in different solids and liquid. Pressure of fluid is the force per unit area of the fluid. In other words, it is the ratio of force in a fluid to the area of the fluid held perpendicular to the direction of the force. Pressure is denoted by the letter P here, and if we will see its unit, it will be Newton per meter square. Now how we will link the fluid pressure in the gas, means how pressure depends in the gas with regard to the amount of the substance containing in any container. The pressure of a gas results from the collision between the gas particles in the walls of the container. Each time the gas particle hits the wall, it exerts a force on the wall and increases in the number of gas particles in the container, increases the frequency of collision with the walls, and therefore the pressure of gas increases. Now coming to the next property, which is very important here, viscosity. In general terms, viscosity is the property of the fluid which act between the two layers of fluid, or we can say it is a frictional force which act between the different layer of the fluid. So viscosity is the property of fluid due to the cohesion and interaction between the molecules which offer resistance to the shear deformation. Different fluid deforms at the different rates under the same shear stress. Fluids with high viscosity, let us take the example of syrup, which has very high dense, so it will deform very slow rather than the viscosity of the water, because water has a very less viscosity. So if you will apply the force on the water, it will easily deform or easily move. But in the case of honey, ketchup or toothpaste, it will not easily move, because the viscosity of honey is greater than the water. And if we will take the ketchup, you can see in the image it is a more viscous than the honey, and the toothpaste is a more viscous than the ketchup. So it will take a large force to move or the deform. So it means the viscosity is the measure of how capable it is of flowing. In a liquid, viscosity decreases with increase in temperature. In the gas, viscosity increases with increase in the temperature. Here I have shown the effect of the temperature. How will viscosity will behave upon the temperature? If we will increase the temperature, what will be the effect on the viscosity? So the fluid may be of two types. First, if we will discuss about the liquid, in the case of the water, if we will see the effect of temperature in the case of liquids means water, honey, ketchup and toothpaste. I am taking the example of water. If we will heating the water, what will be the effect on the viscosity? If we will heat the water or the fluid molecules, the cohesive forces become the less, and the attraction force between the molecules of the liquid will be the less, and it will become a less viscous. Whereas in the case of the gases, if we will heat the gas, what will be the effect on the viscosity? The viscosity of gas depends on the randomness of the molecule behaviors of the gases. If we will heat the gas, the molecules will move with high velocity and collide largely to each other, and it will affect in increasing the viscosity of the gases. So the behavior of the viscosity with the temperature is different in the fluids. If we will taking the example of liquid, the viscosity will decrease, whereas in the case of the gases, the viscosity will increase. Now coming to the types of viscosity. Viscosity is the measure of fluid's friction to its flow. There are basically two types of viscosity we will discuss in the fluid dynamics: dynamic viscosity and the kinematic viscosity. We also say the absolute viscosity to the dynamic viscosity. One way to the measure fluid resistance to flow when the external force is applied on any fluid, this is known as the dynamic viscosity and generally denoted by the mu. Other way is to measure the resistant flow of the fluid under the weight of the gravity. Only gravity is acting on the fluid. There is no other forces acting on the fluid. That time we calculate the kinematic viscosity, and the kinematic viscosity is calculated by dividing the density to the dynamic viscosity. Coming to the next part, Newton's law of viscosity. Newton here defined one law of viscosity in which he says the shear stress is directly proportional to the velocity gradient. You can see the formula tau is directly proportional to the velocity gradient du by dy. The shear stress between two adjacent layers of the fluid is directly proportional to the negative value of the velocity gradient between the two adjacent layers of the fluid. Here in the formula you can see the tau is the shear stress and mu is the viscosity, whereas the du by dy is the rate of shear deformation. So by using this formula we can calculate the shear stress acting on the layer between the two layers of the fluid. According to the Newton's law, there are two types of categories of fluid. The first one is the Newtonian fluid, which obeys the Newton's law, and the second one is the non-Newtonian fluids, which does not obey the Newtonian law. The fluid whose viscosity remain constant is known as the Newtonian fluid. The fluids are independent of the amount of shear stress applied to them with respect to the time. The relation between the viscosity and the shear stress of this fluid, if you will see, is the linear. For example, water, here the shear stress is linear to the viscosity in alcohol, in mineral oils and gasolines. All these liquids have the linear relationship between the viscosity and the shear stress. Now coming to the non-Newtonian fluids, this fluid does not obey the law of Newton. The fluid whose viscosity changes when shear stress is applied is known as the non-Newtonian fluid. These fluids are the opposite of the Newtonian fluid. For example, toothpaste, ketchup, cosmetic paints. So when shear stress is applied to such type of fluids, so it's not linear or it behaves differently on applying the different stresses. Now coming to the types of non-Newtonian fluids. So non-Newtonian fluids are further classified in different types of fluids. Like first one, we will see the dilatant category. The viscosity of the fluid increases when shear stress is applied. Means if you are applying any force in such type of fluids like corn flour with water and putty, just generally used in construction part, are the example of dilatant fluids. If you are applying some forces in such type of fluids, it will be thicker. Means it's getting more thick and thick if you will apply a large amount of force. So its viscosity is increasing on applying the forces or the shear stress. Now coming to the next pseudoplastic category, the viscosity of these fluids decreases when shear stress is applied. Means if you will apply the forces on such type of fluids, its viscosity will decrease. Means it will be thin. As you apply the force, it will become more thin and thin. For example, ketchup. Ketchup is an example of pseudoplastic, and its behavior is opposite of dilatant fluid. And the third one here is the rheopatic. The viscosity of these fluids increases when shear stress is applied along with the time. Means here you can see it is somewhere is like to the dilatant fluid, but it depends on the time. Means if you are applying a force with a long time, then it will become a more thick and thick, and the viscosity will increase. They are similar to dilatant fluids. However, these fluids are time dependent. For example, cream, gypsum paste, and are the example of rheopatic fluids. And the last one is thixotropic. The viscosity of these fluids decreases when shear stress is applied along with the time. For example, cosmetic paints are the example of thixotropics. Means if you apply the forces in such type of fluids like cosmetic and paints, it will become thin with the time and its viscosity will decrease. Here I have shown you the two images or two graphs with viscosity and stress, how dilatant and pseudoplastic fluids behaves with applying the stresses. In first image you can see if you will increase the stress on dilatant fluid, the viscosity is increasing. Whereas on the pseudoplastic, if you will see, on applying the stress, it become more thin and the viscosity is there decreasing. Now coming to the next graph, if you will apply the stress over a time, means with increasing of the time, you are applying more stress. So in rheopatic, you can see the viscosity is increasing with the increase of the time and increase of the stress. Whereas in the thixotropic, you can see the viscosity is decreasing with increase in time and increase in the stress. Now coming to the next property, specific volume. A specific volume is the volume of fluid which occupied per unit mass. It is the reciprocal of the density. Specific volume is denoted by V, and the unit you can see here is reciprocal of density, so it will be the meter cube per kg. Means the 1 meter cube, if in general we can say 1 meter cube of volume containing 1 kg of mass. So the specific volume will be 1 meter cube per kg. Here I have shown some example in the air. If you will see what is the specific volume of the air, it is 0.78. In the ice, you can see the specific volume is 0.00109 meter cube per kg. Means 1 kg of ice can be contained in 0.00109 meter cube. Whereas if we will take the example of air, means 1 kg of air can be contained in 0.7 meter cube. Whereas if we will take the example of water or liquid, 1 kg of liquid can be contained in 0.00100 meter cube. Whereas a salt water can be contained in 0.0097 meter cube. And there are more examples of R22, ammonia and carbon dioxide. Means how much amount of volume is required to contain the 1 kg of mass. Now coming to the next property, specific weight. Specific weight is the weight possessed by the unit volume of a fluid and denoted by the W. Its unit is Newton per meter cube. A specific weight varies from place to place due to the change of acceleration due to gravity. Here I have taken some example of water at 1 atm pressure and 10 degree temperature. If we will see the density of the water at 10 degree Celsius and 1 atm pressure is 1000 kg per meter cube. And now if we want to calculate the specific weight, means in Newton per meter cube, so we have to multiply it by the gravity. Means simply it's a weight by volume. In density we calculate the mass by volume, while in specific weight we calculate the weight by volume. So we have to simply multiply it by the gravity. So if we will multiply 9.81 meter per second square to 1000, it will come to the 9810 Newton per meter cube. And in second case, we have taken the water at 1 atm pressure and 20 degree Celsius. So the density at 1 atm and 20 degree Celsius, you can see here, is 998 kg per meter cube. So if we want to know the specific weight of the water at 20 degree Celsius, so we have to multiply by it by 9.81. So it will come to 9790 Newton per meter cube. Now coming to the next property, specific gravity. Specific gravity is the ratio of a specific weight of the given fluid to the specific weight of the standard fluid, and generally denoted by the letter S, and it is a unitless property. Here I have shown you the example. Here given mass is 42 gram, volume is 5 ml, and density of water we know the 1 gram per ml. Then the density of the object will be the mass by volume, 42 gram divided by 5 ml, so it will come 8.4 gram per ml. So if we want to know the specific gravity, we have to divide the density of the object by the ideal fluid, or if we will take the ideal fluid as a water, then we can divide the density of water in it. So density of object divided by density of water, 8.4 gram per ml divided by 1 gram per ml, you can see here, is 8.4. So the specific gravity of the object will be the 8.4 here. So thank you. This is enough for the basic properties of fluid, and we will further discuss in our next lecture. Thank you very much.